All right, page 20. The next couple pages are about equivalent expressions. And the word equivalent means that, that we might be in different forms, but we have equal values. And when I say equal values, that might be actual values, like the numbers are equal to. It also could mean same graph or same table of values. And then there are kind of two ways to go at this. There's the old school. We're doing some hardcore algebra and getting that job done. And of course, then there is all of our Desmos tricks to get through this. These are 6 to 8 points maybe. And as you guys know, that's almost a quarter of what you need. So equivalent expressions kind of breaks down into 3 categories. And I think, honestly, I'm going to break this video into 3 videos. So you're going to need to pay attention to the page that I'm on and where I'm going with this. So the first thing we're going to do is kind of realize that there are 3 categories. The first category we're going to do is factored form. Okay. And then if you just kind of want to break your paper into thirds here, the second type is going to be, a simplified polynomial after adding, subtracting, multiplying, dividing. So I'm just going to put after PEMDAS, because those are our operations. It's not quite as hard as that, but it's a nice abbreviation. And then our last category of equivalent expressions falls under expressions with exponents. All right, so for this video, this first one, this is equivalent expressions 1, we are going to focus on reviewing factoring and factored form. Okay, so there are 3 different types of factoring that we can use to factor expressions completely. And when we are in factored form or not factored form, they have to be equivalent. So our 3 types of factoring. We have GCF, which stands for greatest common factor. The second type of factoring is difference of perfect squares. And then our third type of factoring is factoring trinomials into 2 binomials. Okay. So let me kind of give you a quick example of each, and then we're going to do 2 questions together to kind of model old school as well as Desmos tricks. All right. So our first example is in greatest common factor. I have the expression 4x squared plus 10x. And the command is to factor it. Now we see this sometimes in questions where it asks us to factor completely, and sometimes the very first thing you want to look for is a greatest common factor. So if you notice the numbers 4 and 10, both 4 and 10 are even, so both 4 and 10 are divisible by 2. Now, what's cool about the x squared and the x, they are both divisible by x, which means we have a GCF of 2x. So the way that we did this was we said, hey, we're going to factor out the 2x. This is like undoing the distributive property, which means I'm going to divide this by 2x, and I'm going to divide this by 2x. And then I always kind of talk about how on the parentheses, I write down the leftovers. So when I do 4 divided by 2, I get 2. When I have x squared divided by x, this is 1x, so I only have 1x left. Can you guys see that if I go 2x times 2x, I get 4x squared? I get back to the beginning. Now this operation, the addition sign is just going to come down. And then I have 10 subtracted by 2, which is 5. And these x's, x divided by x is the number 1, or the cancel. So that's going to be gone. So factored form of 4x squared plus 10x is equal to 2 times the GCF times the remaining factor, which is 2x plus 5. All right. Another type of factoring is a difference of perfect square. Now, difference means subtraction. So we might have something like 4x squared minus 81. Okay, so the first thing is, this is a subtraction problem, and that's the word difference. But the other thing is understanding that both 4 and 81 are perfect squares, and x squared is a perfect square. If I take the square root of 4x squared, I'm going to get 2x. And if I take the square root of 81, I'm going to get 9. So the idea of perfect squares is that something times itself is the product that we have. So when we factor a difference of perfect squares, we're going to get 2 binomials. So those butt cheeks need to touch each other there in the middle. And we're going to have one binomial, which is 2 terms with a plus sign, and one binomial with a minus sign. And they're going to be what's called a conjugate pair. But basically then, it's kind of looking at your double distributive. So I need 2x times 2x to get the 4x squared. And I need 9 times 9 to get the negative 81. So what's going on when we actually double distribute, the middle terms, the x terms are going to cancel out. And that's why you only get this binomial up here when you multiply these two binomials together. So the factored form of 4x squared minus 81 is equivalent to 2x plus 9 times 2x minus 9. All right, so our last one is trinomials. And some of you may have learned a magic X game, or you would have learned an add multiply method. So let me give you an example of that. So we have x squared minus 6x plus 8. So here's a trinomial because there's 1, 2, 3 terms. Your teacher may have then done one of two things or both. They put an A over this, maybe they called it AM method, and then an M over that. So what they're actually doing is they're looking for two numbers that add to make negative 6, that multiply to make 8. And so what I'm doing is the magic X game here in the middle. So if I go to think about the number 8, There's not a ton of numbers that multiply to make 8. It's 1 times 8 and 2 times 4. And so when I look at that 2 and that 4, I see the number 6 when I combine them. But what's special about this to get the negative 6 is both of these have to be negative, right? So a negative 2 times a negative 4 makes a positive 8, right? Positive 8. But a negative 2 plus a negative 4 gives us a negative 6. So these two numbers are going to help us make our binomials. And so our binomial is going to be x minus 2 times x minus 4. And so those of you that then can want to check your work, you would double distribute. And you would see that this makes negative 2x and this makes negative 4x, which combines to make negative 6x. A negative 2 times a negative 4 is a positive 8, and x times x is x squared. Okay, so that was a lot of information about factoring. And it's good to be able to factor because sometimes you can squeeze a point out of an open-ended question. But let's look at some multiple choice and see how we're going to beat the Regents. So go ahead and turn the page. And the very first question we're going to look at is question number 1. And it says, and this was the first question on an exam, what is the correct factorization of this? Which means which one of these 4 choices is equal to this trinomial. Pause for just a second and look at the 4 choices. All of them are binomials times binomials. That means 2 terms times 2 terms. Then we have 3s and 4s, and we have 2s and 6s. Well, that makes sense because 3 times 4 is 12, and 2 times 6 is 12. But we need to also get a positive 4 here in the middle for the add. So let me show you on Desmos how we can do this problem and kind of cheat it so we don't necessarily have to do the factoring process. So if we go here and just delete and start, the first thing you're going to put in is the question. So the question becomes, the question is x squared plus 4x subtract 12. And I want you to notice that this expression made a graph. And in fact, it will even make a table of values. So I don't have to put x and I don't have to put y equals. It'll automatically make that table for me. Now I'm going to get rid of the table temporarily. I'm also going to back out so I can see more, because when I'm looking at parabolas, I definitely want to see that turning point. It has to be a perfect match if it's going to be equivalent. So now I'm going to use these to practice the 4 choices. So the first one is x plus 3, x minus 4. Okay. Does the red graph match the purple graph? No. So there's 2 options. You can edit what you have here, or you could just turn it off and move on to the next choice. So I go to the next choice, x minus 3, x plus 4. Oh, well, my black graph doesn't match either. Now, I got to admit, those 2 were not going to be ones that I was too concerned about, because I'm going to go back here to the way that you learned how to factor, and that was with AM factoring. So x squared plus 4x minus 12. You need 2 numbers that add to make positive 4, that multiply to make negative 12. So I set up my magic x, and I want to multiply to make negative 12. And to multiply, I need a positive number and a negative number. And I want to add to make positive 4, which means the larger of the 2 factors has to go on the positive side. So it has to go over here, okay, because this is positive. So going back to my options, I want a positive 6 and a -2 because 6 minus 2 is 4. So I think the correct answer is choice 4. I'm going to go and double check that no matter what. And this is how I would tell any kid to confirm that they have the right answer is you check your work. So I'm going to go up here to this one and I'm just going to change it to what I think the correct answer is. And it says subtract 2 and plus 6. I need to turn it back on. There it is. So if I turn it back on, notice that it's the same graph. If I go here, there's one table. There's the other table. Let me just get this down out of here. And you can see they make the same exact table. So same expressions, equivalent expressions, same table, same graph. So back in our book, the correct answer to number 1 is choice 4. All right, so now I'm going to have you turn the page again, and we're going to go to question number 30, where it says factor completely. So when you have the word completely, that tells you there's probably going to be 2 levels of factoring. And that makes sense. This is an open-ended question. It's question 30. It is a 2-point question. So let's aim to get 1 point. The easiest thing to do on this open-ended question is to look for a GCF. And if you don't remember, GCF stands for greatest common factor. So there's 2 things to look at. We have 20x cubed, and we have a negative or subtract 45x. So there's the numbers 20 and 45 and what they have in common. And then there's the x cubed and the x and what they have in common. So this is actually a trick that's in Desmos. I don't know if anybody would actually ever remember it or need it, but I want to show you because it's fun. Let me just delete all of this good stuff. And down here, remember there's all these crazy functions, and you might be like, who cares? Well, way down at the bottom, there's some ones about number or number theory. And these might be things that you know, least common multiple, greatest common denominator. There's ceiling and floor. There's here's a type of root, like a cube root. And there is rounding, but rounding does not do decimals, if I remember correctly. So least common multiple is moving forward in numbers. Greatest common divisor is a greatest common factor. What number divides both? So I can actually type that in and do 20, 45, and you guys already knew this. Both those numbers are divisible by 5. So the GCF for the numbers is going to be 5. Now, looking at the x's, you can't take out more x's than what there are. Both of these terms have x's, and the least number of x's is just 1x. So the GCF is going to be x. And now put these 2 things together. Our GCF for the polynomial is 5x. So we're going to divide by 5x, and we're going to divide by 5x. But one of the important things to remember to get at least 1 point is the 5x is still part of the answer. It's not gone completely. And then you're going to put some parentheses, and this is what I like to call the leftovers. And it's the remaining factor after you divide or factor out the 5x. We're undoing the distributive property. So 20 divided by 5 is 4. I had 3 x's. I'm removing 1 x, so I'm going to get 2 x's left. I have a subtraction symbol. 45 divided by 5 is 9. And then those x's are going to cancel. So right now, this answer is worth 1 point. We're not done because there is a difference of perfect squares right here. Because the square root of 4 is 2 and the square root of 9 is 3. There's one more level. So the final answer, if you're able to put it together, is 5x. And now this is going to become two binomials. One is going to have addition, one is going to have subtraction, and then they match beyond that. So 4x squared becomes 2x times another 2x. And 9 becomes 3 times 3. And then once again, how can I check my work? Is I would put the original question in Desmos and then check the parts. So if I go up here and start off with 20x, and I'm using the caret symbol to get cubed, just don't forget to get out of that caret symbol, minus 45x. So there's my first expression. The middle answer I had was 5x times 4x squared, subtract 9. Okay, and you'll see that that one's right on top. And then my final answer is 5x, 2x plus 3 times 2x subtract 3. And you'll notice that all three graphs line up. So here, if I turn the purple off, I can put this one here, and then I could turn this one on, and it's underneath, and I could turn this one on, and it's on top. So all three expressions, and I can zoom out as well to see that they do match perfectly. Remember, your home gets you back to the 2 grid. Zooming out once gets you to the Give Me 5 grid, which is what typically our graph paper is like. Last thing before I close this video out, there is one more problem that you can use to practice factoring, and that's question number 30 on page number 23. So here we are, page number 23, question number 30. So that would be the question that I would ask you to tackle, and then look for a worksheet with just a few more, especially of those other types that they have sometimes at the very beginning of the exam with very basic factoring skills. You want to ace those because once again, the multiple choice is there, but you also want to squeeze some points out of the back. All right, so we will return to page 20 in our next video and work on simplifying after operations.